Hello, I'm JW. This time we're going to have a look at testing once again, and it's earth electrode testing this time. Now, earth electrodes are not commonly used in the UK. They may be more common in some rural areas, but most new installations certainly do not require one. And of course, if you have got one though, it does need to be tested and confirmed that it's installed properly and its impedance is suitably low. And therefore we'll have a look at how you can test these. There's the easy method, which we've actually covered in another video, and of course then there's the more difficult and time-consuming method, which is seldom used because it's just too difficult and time-consuming. Now, in terms of earth electrodes, which are those things that you bury in the ground, such as an earth rod, or in some cases it can be other things as well, like a grid or mesh or whatever, then these things do need to be tested, and there's two main ways that you can test these. The first method is to simply do the external impedance test, and that's simply using a two-wire deal between the earth electrode and the means of actual supply to the building. And this is by far the most easy, and hence it's the most common method that is used. However, the problem with this is that it does require that mains power is available, because of course without it you can't actually do this. So on an installation that actually has power available, then that's by far the easiest one, and we've done a separate video on that as well, so let's go and have a look at that one. However, in the case that power is not available, which certainly would be if there was a new installation, power hadn't been connected yet or whatever, then the alternative method is to use an actual earth electrode tester. And this does not require any mains power, they're battery operated, and of course this can be done whether there's mains power available or not. And certainly if you've just installed an earth rod or something and say the actual electricity hasn't been connected yet, then this is pretty much the only choice that you're going to have. This takes considerably longer, and of course you do need the specific piece of test equipment to do it with as well. Now, plenty of multifunction testers have this built in, but certainly not all of them, so if you are going to be putting earth electrodes in on a fairly regular basis, it's worthwhile to get one that does actually include this function. I say some do and some do not. Now, in terms of doing these, we've done a video on this before, so I'm not going to cover that in this video, but what we're going to have a look at is the procedure if you're going to use a specific testing piece of equipment. Now, of course, you're going to have the electrode installed, and here's the ground here, I've just drawn it in brown here, and here's the sky with the sun in it or something. And your electrode will, of course, be embedded in the ground, and we're going to draw it over here in black. Normally the top is recessed below the ground, but we'll show it above here just for ease of drawing. So that's your electrode that you've installed, and now you need to actually use the testing equipment to confirm that it's in actual working order and its impedance is sufficiently low. And typically the testing equipment will have three connections, and so this could be part of another multifunction device, but three wires coming out of that. First wire of which actually just connects over to your earth electrode. Now we're going to draw these in blue because you can actually see them just as well. So one of them goes to the actual earth electrode in the ground. Now the other two wires need to go to two additional electrodes which are only temporary, and generally if you buy one of these things then it comes with this as part of the set. And essentially they're metal spikes with the wires connected, and these need to be placed in the ground a reasonable distance away from the actual electrode you installed earlier. They're not particularly long, usually only sort of 12 inches or 30 centimetres in length or something, although if that's not suitable then longer ones can be obtained. So you need to insert the other two electrodes, say here, temporarily on the ground, and then the other one, say over here. And note this does require that the ground is reasonably soft and you can get it in there. If this is a concrete laden car park or something, well, unfortunately it's game over because you can't obviously just poke these into solid concrete or something. So again, this is probably something done in more rural areas, typically where we would have this type of installation anyway. Now the three wires there will just connect across, so you're going to have a wire from here to this one and a wire from here to this one. Now in terms of the distance these have to be apart, this is fairly important, and it really depends on how deep in the ground this thing over here actually is. And the important thing here is to make sure that the area that's affected by this one does not overlap the areas affected by the other two. And this does vary considerably depending on the type of soil, but a good way of estimating this is to see how far in the ground this is, and of course you'll probably know this because you're more than likely only just put it in there yourself. So let's say this was 2 meters in length in the ground, which will be a fairly short electrode in actual fact. Then the total distance here between this test one here, which we're going to call number 2, and number 1, this distance here needs to be at least 10 times the depth of the initial electrode. So in the case of it being 2 meters in the ground, this distance here needs to be at least 20 meters. So as you can imagine, these test leads are extremely long, and again when you buy these as a set, they do come with extremely long test leads in a big bag. So 20 meters as an absolute minimum distance, and of course if this was a deeper electrode, say it was 4 meters in the ground, then yes, that means you're going to have to go at least 40 meters away, so you could be literally halfway across a field or something. So definitely not very convenient in terms of the other test, and now you can see why the other test is more often used. So total distance there is certainly important, and initially you want to do these so that they're reasonably equally spaced. So in the case of the 20 meters, you would have, say, in the region of 10 meters there, and about 10 meters there, or conversely longer depending on the actual circumstances. And then once you've done this, it's a question of pressing the button on the machine, and then it will tell you on the little display what sort of reading you actually have. Now the reason it has 2 of these is that the device can actually determine whether or not these are connected in the ground satisfactorily by measuring the resistance between the 2, and it does all this automatically. And if you find that it's showing some kind of error here, it means that these 2 are not making sufficient contact with the ground, and if that's the case, you're going to have to either reposition them or put them in deeper, or say get longer ones or whatever else. But assuming that it does actually show correctly, it will give you a reading there in ohms, and that is effectively the reading that you've got. However, that's not the end of the procedure, because that only gives you in those 2 particular positions. What you then need to do is to remove this one, and you need to move it closer to the main electrode over there, and then do the test again, and then take it out again, and then move it further away, so over this side, and again do the test again. So you want at least 3 separate readings, and again you don't want these to overlap, so if this was say 0.5 meter in depth, you don't want to get any closer to this than say 5 meters. And in terms of the distance here, at least sort of 5 or 6 meters either side would be fairly usual. If you've got a very large distance, then of course you can do a bit further as well. Now what you should get from the 3 readings is basically the same. So if you say got 68 ohms initially, then you got sort of 71, and then you got sort of 70. Well, that's fine because they're all pretty much substantially the same, and the actual reading you would get is the average of those 3. So you simply add those 3 together, divide by 3, and that will give you the result in ohms. And again, this is not particularly critical because you're just making sure that it's within the sensible kind of range. If, however, you did the first test and say got 68, and then you did another test and it came up as 140, and then you moved it the other way and it came out as 399, then this indicates there's something gone horribly wrong, and it means that either this is extremely poorly connected, or one or both of these are also badly connected, and in which case you're going to have to try these in 2 completely different positions, and of course maybe do something about the original electrode installed as well. But substantially the same, that's fine. Substantially different is no good, and you'll have to do the test again. And depending on the kind of soil and ground you've got, it may be necessary to repeat this test a considerable number of times until you can actually get satisfactory readings from it. So this is not a quick test. It's not convenient because you're trailing wires tens of meters across a field in most cases, and of course it might be raining and getting dark and cold and whatever else. So you can see now why the other test is used, and this is seldom done unless this is absolutely necessary. Now, a final point here, if you get 3 that are the same, but they're all far too high, so say for example you've got 3 readings that came out as 450, 477, and say 468, well yes, they're all reasonably close together, but the average of those is in the middle of the 400s range, so that is far too high, because what you want to find is something in the range of 100 or less. Then this means that the actual electrode itself, which you put in here, is not sufficient, so you're going to have to do something about it to reduce this value considerably. So what to do if the actual resistance of that electrode is far too high? Well, the first option is to put in a deeper, or effectively longer, electrode. Now the better ones of these are generally supplied with a threaded end, so that you can screw a spike onto one end and drive it into the ground a length of, say, around 1 metre, and then you can get a coupler which screws on the top of it, and then you can attach another 1 metre length on there, and then drive that in the ground, and if necessary repeat again and until you've got as many in there as you can get, or as many as is needed. So that's certainly one option. However, that's only applicable if you can actually do that. If you live in an area that has shallow soil and very hard bedrock, well, that's not going to be working. But that's certainly an option. Option number 2 is to have more electrodes. So if you have the ground here, you could have one in here, and then of course you can install another one over here, and then they would be linked together with a suitable sized copper wire, and of course you could put a third and a fourth, and as many as was necessary. And just as with the test previously, you don't want these to be too close together, because of course if they are, then they'll effectively be in the same resistance area, so these do need to be spaced apart a considerable distance. So in the case of, say, a 2 metre electrode, you'd be wanting to put the other one sort of 20 metres away or something to make sure that it's in a completely different area. And if you're going to have 3 or 4, then again this could extend over a considerable distance. The third option is something else. And by something else we don't mean just not bothering, but what we can do is, of course, not just have, say, a spike in the ground. You can things like have a grid in the floor. So instead of that, you would have literally just a metallic grid, which you can then just excavate a large area and then bury this underground. Very handy if there's some new buildings being put up, because concrete generally has this kind of metal grid inside of it. So if you can get a piece to be left accessible at one edge or the particular location, you can actually use that as your earth electrode. There are also things like tape, generally made of copper, so you can dig a long trench in the ground and then you can lay in the copper tape for a distance of many meters and bury that inside. And there's several combinations, obviously combinations of these, or rods and tape and so on. So whatever's necessary, and it really depends on the actual area. If you live in, say, Cornwall and you've got solid granite, you're not going to be driving earth rods into that, so you're going to pretty much be condemned into using grids, tapes and that kind of thing. And pretty much any metallic object buried in the ground would do. So even if you had, say, on a farm or something, some old disused water pipe that went across a field for 300 metres, if that's not being used for water anymore, you can certainly connect to that, and that would make a fairly good earth connection. So that's earth electrode testing. And say something that's not necessarily done all the time, because many installations don't actually have one, but clearly if they have got one, you do need to do the test. And certainly if mains power is available, then it's certainly recommended to do the impedance test using the mains power there, because that's much quicker and easier than doing the test with the 3 leads and all of that. And the only thing to bear in mind if you are going to test it using the mains power is to make sure there's nobody in the vicinity of the electrode when you're doing the test, particularly if you're going to use an older test device. As when you're actually basically connecting that to the test machine, then there can be an exposed voltage occurring on and around the position of the electrode. Now, most modern test equipment, in fact probably all of it, will limit the voltage there to either 25 or 50 volts, but certainly some older equipment, the ones that Claire made for example, doesn't, and you can in fact get some fairly dangerous voltages appearing there, so just bear that in mind. So not particularly relevant on new equipment, but older test equipment it certainly is.
Young English Engineer, your way to the electronics world. Like our Facebook page and learn more. Project provided by Tesla Institute, School of Electrical Engineering and Automation.